Hello everyone, I'm Kritika and my student ID is 862392481 and my email is kbhal004@ucr.edu. So my topic for today is spatial technologies hands-on and I'm using GeoPandas for the same. First, let's run through the advantages of GeoPandas. So first of all, we know that GeoPandas is open source and it is community supported. That is, it does not require any kind of subscription or premium analysis model. It is free for everyone. Second, it has powerful data handling. That is, it is efficient to store large data sets and make suitable and complex spatial data analysis. It is compatible with multiple data formats. That is, you can use JSON, GeoJSON, shapefile, which I would be using in the project, and other kinds of vector data formats with greater flexibility. It is seamless in visualization. That is, it can be integrated with Matplotlib, leaf map, which I would be using in the project as well. And you can see the plots very clearly and efficiently. The last advantage of it would be its integration with Python libraries is very efficient, which means that we can perform data analytics tasks and integrate it with other Python libraries like GeoPy, NumPy, Pandas, scikit-learn, SciPy, etc. And it has a wide range of applications because of this compatibility. Moving on to the project. So for this particular task, I have used Hurricane Evaluation Center's dataset. That is the dataset of hurricane evaluation centers in New York City. And this is basically an Excel sheet, and it would address the hurricane shelters in the city of New York. So the procedure is such that first we would read the Excel file using Pandas. This step requires the Open PyExcel package that Pandas provide. And the dataset contains 64 addresses of hurricane evaluation centers in New York City. It is a very skewed dataset since we have only chosen one particular city in New York, in USA, which is one of the major cities. And that is why I have skewed my analysis to just New York. After that, we would pre-process the dataset. As we know that we are using GeoPandas, so we would need to geocode the entire dataset and sort the address in a format that can be geotagged. And that is where the major task of pre-processing would be required. Moving on to the project. So this is the Excel sheet that this is the Colab notebook that I have prepared for the project. And over here, I would first execute the entire notebook and then walk you all through the entire step-by-step procedure. One second. So first, I have installed certain Python libraries, that is Shapely, GeoPandas, OpenPyXL, as I had mentioned before, and LeafMap, which is used for visualization. So let these libraries get installed. Once they are done, I have used certain imports that are required. So this one zip file import is just for the ease of usage of the model so that I can store the output in the form of zip file as well. So as we can see that the initial cells have been done. So over here, I'm just creating two output directories. That is, one is for the data input that I would be providing in the form of Excel sheet, and the other is the output directory. So when it comes to data, I'm using this URL as. So once we visit this URL, one second, you can see the entire data set. It has certain rows and columns, but it is only skewed to New York City. And it has given me the chance to download the data set as well. One second. So as we can see that the data set has 64 rows. And this is the city. There are different cities like Brookline, New York, and other cities. This is the name of the street. This is the exact address of the evacuation center. This is the zip code, and this is the borough code. This is the state, and these are just the these are just the binary values of whether that center is available. And as we can see, all the centers are available. So this particular column is a Boolean column. But over here, it is very evident that the address is not in a consolidated format. So if I have to select the latitude and longitude coordinates in order to geotag, it would not be a very efficient task. So first, I would have to convert the dataset, the address specifically, into a consolidated format, and then perform my analysis when it comes to geocoding and other things. So that is what I would be doing. So my initial task would be to concatenate the address in a consolidated format. So so I've given an example over here. So my initial task would be to convert this particular address into this format, because when you geotag a particular address in the form of string, you would require so when you geotag an address in the form of string, you require the exact location and not an arbitrary location. So this is sort of a regex function that I have written for the address. It is a very extravagant regex function because I want it to be precise enough. Once that is done, I have appended a address fixed column at the end of the dataset, as you can see over here. So this is the fixed addresses, not the fixed ones, but rather the address in the format which I would want for the analysis. After that, I have also created another column called full address column, which has like the street name, the state, the city, and the zip code as well. So this is the entire address. Further, we would start with the GeoPandas. So all this was just the pre-processing that was required. Once that is done, we can start with the geocoding procedure. So when it comes to geocoding, basically we are taking the entire address and then we are copying it into the spatial thoughts locator. And this locator can find the exact latitude and longitude on the map. So this is the entire geocoding task that we would be performing here. And we have used the TQDM notebook, which is another extension of Python for spatial data analysis. So over here, we have gotten the entire location in the format that I have mentioned before. Once we have the entire location, we would then work on the latitude and longitude, which are the most essential form of data. So here we capture the latitude by locating it on the map and then applying the LOC function of pandas. And in the same way, we find the longitude. Once we have the latitude and longitude, there are still certain addresses that do not have a precise location, which means that the latitude and longitude could not be got. So that is why we are just filtering that data out. So we are filtering the missing values over here. Once we have filtered the missing values, we add another column to the dataset that is called geometry, which sort of combines the latitude and longitude coordinate so as to get the data point on the map. So this is the entire data point that we would be working on when it comes to plotting the place on the map. Once that is done, the final procedure is to use leaf map, which we have used over here, and plot the entire point on the map of USA and on the map of USA. And I have also zoomed in so as to show you the entire city of New York and all the 64 hurricane centers. So when I hover over a particular point, I can see the name of the center, the exact address, and the latitude and longitude coordinates. So that is something I have coded over here, and I have kept the color red because it should be seen from far. And one more thing, when it comes to like storing the output, I have used the Shapely library, and further I'm converting the given output map into a zip format and then downloading it as well. So this was the entire execution of GeoPandas, and